IP version 6. As you know, IP version 6 is the next version of IP addressing which was released after IP version 4. So if you get back to our basics of IP addressing, IP address is a logical address which is given to each and every device in the network. Now every device in the network must be identified with some IP address. It's a layer 3 address and it's going to identify each and every device. So we got two different versions of IP addressing, which is IP version 4, which we have been using still. It's a 32-bit address written in decimal format, whereas we got another version of IP addressing, 128-bit address, which will be written in hexadecimal format. So now what is the reason for a new version of IP addressing called IP version 6? Now the main reason is the shortage of IP addresses. Now whatever the addresses we have here, like the IP version 4, which is 32-bit address, it's going to support to the power of 32 addresses. So it's going to support somewhere around 4.3 billion IP addresses. Now whatever the addresses we have, these addresses will not be enough to meet the growing network requirement. Now you know the internet is growing at a very high rate. So the number of people connecting to internet it's a very big network. So whatever the addresses we have here, it will not be sufficient to accommodate all the users. So to overcome that, there are two possible solutions developed. Like if I talk about IP version 6, it was released somewhere around 1999 June. A full-fledged IP version 6 was ready to release in the market, so which means ready to implement. But still, they also come up with some temporary solutions like NAT. Later on IP version 6, there are some techniques introduced which was to overcome the shortage of IP version 4, or we can say these techniques, whatever we have listed here, it's extending your IP version 4, in other words we can say, or we can even say that it is hiding your IP version 6. Now because of subnetting, we can efficiently utilize the IP addresses, and then we have design CIDR way of designing the addresses, and then we have a translation called NAT, and using NAT we can allow more than 60,000 private IP addresses can go with a single public IP address. Now we are still surviving with IP version 4 because of NAT and these concepts. But from the last 10 years, we have been extending the IP version 4. But definitely, even though these are the temporary solutions to overcome the shortage of IP addresses. Now, alternatively, we need to definitely go with IP version 6. Now, IP version 6, it has been made mandatory, like whatever the new operating systems coming into the market, let's say, starting from Windows, if I say Windows operating system, Windows Vista, Windows 7, Windows 8, even the new Cisco iOS coming, new Cisco iOS versions, they all by default support all the IPv6 options. So means every device nowadays is capable of identifying and understanding the IP version 6 addressing. So at the same time, as a network engineer, we also need to have a very good foundations on IP version 6. So in this section, we'll be getting into much more in detail about IP version 6 from the basics. So before I move on with IPv6 addressing, I'll give some advantages or extensions, or even we can say some of the features what we have when compared with IP version 4. So IP version 6 is going to definitely provide a very large address space, which means it's going to provide to the power of 128 addresses. So somewhere around 3.4 into 10 to the power of addresses, means each and every human almost can get a one single IPv6 address. Now at the same time, even if the internet grows more than double every year, let's say, still for the next 50 years we can survive without any shortage of IP addresses. So definitely it's going to provide a very large address space, which means we don't really need to do NAT. Network address translation is not required here up to now. But in case if we come across shortage, maybe in the future means it will be not less than 50 or 60 years, you may need NAT. Probably up to now there is no need of NAT here, and the header format is more simplified here, and it's going to increase the efficiency on the routers because of the simple header, and the addressing is much designed in an aggregation based hierarchy, and there is no broadcast here, which means like we have a broadcast ID which is used to send a broadcast to all the devices within the network, and now here we don't have any broadcast ID or any concept of broadcast here. So we'll get into that categories of addressing, like unicast, multicast, anycast, broadcast, those things probably in our next section. Now here I'm just giving you the overview of the things. And also it supports something called stateless auto configuration. Now in stateless auto configuration, a device can get an IPv6 address by including its own MAC address. Now this probably will get into much more in detail in a separate section, where I will show you how it is possible and what are the specific configurations required to make it possible. So next, it also supports built-in support for mobile IP, where you can have an IPv6 address and you can move around. That is built-in support. Also we have in mobile IP, and also it has inbuilt IPsec feature, which means inbuilt security in IP version 6. Whereas in case of IP version 4, we need to integrate with IPsec feature to provide some high-end security. Whereas in IPv6, by default, we have an inbuilt IPsec security inbuilt, and easy way of IP address renumbering feature. And then one more advantage we can have is we can have a multiple interfaces on a single interface, which means, take an example, if you go back to IP version 4 on a single interface, let's say I'm on the router, we need to say IP address, and then we are going to assign one IP address 10.0.0.1, and then I'm going to assign the subnet mask. At the same time, let's say if I want to assign one more IP address, so I can go and write IP address and I can say 11.0.0.1 and whatever the subnet mask. So when I'm going to write this command, automatically it is going to override the previous IP address. That is something what we have in IP version 4. And if you don't want to override, if you want to use both the IP addresses, then we have a keyword called secondary we can use. So this is the way we can have a single interface can have multiple IP addresses, but still this is going to be preferred over this one. But in case of IP version 6 on a single interface, I can assign both the IPv6 address. Let's say I want to assign a private IP address, which will be used in my LAN communication or within my company network. And the same interface, I can also have a public IP address. And in fact, you can have more than that. Now, if a traffic is coming from one network, it's going to use the private IP. It all depends upon the source from where it is coming. So depending upon the source, it's going to select. Now that is one good thing. Anyway, I'll show you when we get into the practical labs. Probably I'll show you how to assign the IPv6 address as well. The next thing we'll see, we'll try to get into understanding how the IP version 6 exactly looks. Now if you see here, I got one sample IPv6 address here with 2001 0dp8 0000 0000 1234 and all zeros and 3C40. Now by default, IPv6 address is a 128-bit address. Now we got 128-bit address, and then it will be written in hexadecimal format, which means total there are 128 bit and each portion is going to represent 16 bits here.